So hello, it's me Atharva, and today we're going to talk about the question Lucky Maggi. So essentially this question was in the contest that we had, and in case you haven't checked out the question, make sure you go into the link will be given in the description, make sure you check it out, and then only jump back to the editorial solution that I'm going to present today. So essentially we're going to code the solution in C++, and I will even give you a walkthrough to the code in Python. So yeah, let's get into it. So first, let us understand what the question actually was, right? So this is just the useless part of the question wherein the context is given, but the main question comes here. So there are n students who are participating in a lucky draw. Okay, so there are n students. A student is participating in lucky draw. Each and every student has a unique number given to them. That is a of I. So what does this mean? The student number 1 has a number given to him, that is A1. The next student will be given A2. The third student will be given A3, and similarly the n student would be given the number AN. So basically all of these numbers are unique. And what is the condition for a person to be lucky? So a person is considered to be lucky if we can express A of I as product of two integers, that is n cross m equal to A of I. So basically what is n and m? Basically 3 into 3 equal to 9. Here it need not be distinct, because in question nowhere it has been specified that these two integers can be distinct, right? So it can even be like n is equal to 3, m equal to 3, so 3 into 3 equal to 9. So 9 is A of I. So basically n and m, what are these? These are the factors of A of I, right? So the condition here is if the number of possible permutations of n comma n is odd, then a person is considered to be lucky. So what does this exactly mean? Let us understand. So look, if we have given a number 9, let's say, how can 9 be written? 9 can be written as 1 into 9. It can be even written as 3 into 3, and it can even be written as 9 comma 1. So basically these are the permutations we have, right? So what does question say here? Question tells us that if the number of possible permutations of n comma n, that is 3 we have, is odd, then the person is considered to be lucky, or else he is unlucky. Simple, right? So here the number of permutations is 3. 3 being odd, the person is lucky. But now let us take some other examples. Let's say 16. How can 16 be written? 16 can be, let's not take 16. You will understand why. I'm giving you another case. So first case was when it's a perfect square. Now taking another case that is 10. How can 10 be written? 10 can be written as 1 comma 10. I mean 1 into 10, that is one permutation. Another permutation is 2 into 5. The third one is 5 into 2, and the last one is 10 into 1. So total we have 4 permutations, right? What is 4? 4 is even. What does question say? Question tells us that if it is odd, then if it is where is it? Yeah. So if the number of permutation of n comma n is odd, then it is lucky, or else he is unlucky. So here we have 4 permutations. Hence number 10, like the student who has A of I as number 10 is unlucky. So the logic behind this is whenever we are going to have a perfect square. So if we have 25 can be written 1 into 25, 5 into 5, and 25 into 1. So a perfect square is always going to give you odd number of permutations. Why? Because look, if you can write A into B, then obviously A into B is equal to B into A, right? But what if A and B are equal? In this case, A and B are equal. So this is just one permutation. But to other cases where A is not equal to B, like if this is A, this is B, so here A is not equal to B, right? So here A is not equal to B, here A equal to B. So when A is not equal to B, then you can obviously have 2 permutations for it. One is A comma B and other one is B comma A, right? So you can always have these 2 permutations, and hence the number of permutations of n comma m is going to be even. But in case you have same number, if A equal to B, then 5 comma 5 is not different from 5 comma 5, right? And hence you just have one permutation for this, and hence making it an odd. So basically, I hope you have understood the logic behind it. So just the thing is that in question we have that, let's look at the output condition. So if a of I is lucky, then output 1 or else output 0. So basically, if a of I is a perfect square, then that person is basically lucky, because he has odd number is lucky. So he has odd number, hence output 1 or else output 0. So that is all that you wanted to do in this question, just to figure out if a number is a perfect square or no. So now let's look what the input case is. So input over here is, first line of input is number of test cases. I hope you know what number of test cases are. Then second line is that it contains an integer n. N is basically how many students. And next is the total number of space separated integer a of I. So basically, each and every student what value he has, as we know. Now how are we going to code this? Let us get into it. So firstly, we know we need to take the input of number of test cases. I've taken int of t input, then we'll get the t input, then we are learning while loop, and we are calling this function. It's basically just that we have to write our main code over here. So I hope you know these basics if you are doing C++. Now what should we do? We should take the second line of input is n. So let's do this long. Okay, let me make it cn. I'm taking the input. I've taken the input, number of students I've taken. Now what do we have? We have space separated integers. If you look at the example, we have 1. There are 4 integers, 3, 8, 1, 12. So is 3 a perfect square? 4 is basically n, right? So how many students are there? Is 3, the first a1, is that a perfect square? No, output 0. 8, is that a perfect square? No, output 0. 1, yeah, it's a perfect square, so output 1. 12 is not a perfect square, and hence output 0. That is basically the thing. Now let's make if you want, you can make an array, but here I don't feel the use of making an array and wasting your space for any reason. So let's do one thing. Let's use the for loop. When we are taking the input, we are running it for n times, then long. Let's define a variable person. Long is not defined. Int. I've taken int in person. So this is basically I have taken the input. Now I want to check if this thing is a perfect square or no. So how can we do this? Let's make a function perfect underscore square of person. So if it's a perfect square, then see out. Actually, there's no such function called perfect square. Okay, we're going to return this right now. We'll make a function about for this. See out 1. If it's a perfect square, see out 1. No ended. See out 1 or else see out 0. Yeah. So basically this is the thing. If it's a perfect square, see out 1 or else see out 0. Then 0. And at the end, see out and now let us make a function. Like we have a function over here, perfect square. So let's make this function. It returns it's if, so it returns a boolean type. This is the function name, int of x. So x is the input, boolean is returning. So primarily let us make this if x greater than 0 or equal to 0. Let's keep equal to, because if it is negative, then obviously the square root would be imaginary, so no sense of doing that case. So if x is greater than 0, if x is positive, means if x is basically a perfect square, right? So I don't want to consider imaginary cases, as that is not something that we're going to deal with. So if x is greater than 0, then true or false, that will discuss. But if it is negative, then return false immediately. Now int, if x is greater than 0, let's store the square root x square root equal to we have stored this. And now if x square root into square root, there's no need of doing that actually. Let's return it directly. Return x square root into x square root equal to x. That is basically what we want to return. Yeah, so basically this is the thing. Now this is the final code that we have. Let us run this. Let's see if this works. Basically, yeah, this is working. This is working perfectly. So what are we doing here? We are first taking square root. If the square root is the square root of x, square root of x, we multiply that, and if we are getting x that is equal to x, then it will return true automatically because it is boolean, or else it will return false. So basically this is our code. Now I hope you have understood what we have done. We are just taking the square root of it. Now let's sum in this question. Yeah, so here we are. Now let us look at the code in Python. For those who don't know C++, here you are. So we are essentially doing the same thing. We are running a for loop, right? Why are we running this for loop? It's basically number of test cases. That's why we are doing this. Then I'm taking input as n, number of students. Then we are making a list. Actually, list is not necessary over here. We can do it in the way I did in C++ code in case you do not understand. But anyways, let's understand, because this is not going to give you a lot of memory error, because this is still a really small thing. So you are taking the input space separated integer as the number of a student. Then what are we doing? We are going to a for loop. Okay. In for loop, what are you doing? You're calling a function over here. What does this function do? Essentially, if you have a of I, then you will take the input and you'll call this function. If that function, if first we are doing square root of n. So if your a of I, you will do square root of that. If the square root of a of I into square root of a of I, if that is going to be equal to a of I, then basically that's a perfect square, or else it's not going to be a perfect square. So that is the logic. So for square root, so basically root, you have taken the root, the square root has been stored here. Then if you do the square of this root, if that is going to be equal to number, then return 1, then that is a perfect square, or else return 0. So basically that is the code. I hope you have understood this question. Stay tuned for the next one.